Encourage the development of an eco-industrial network that takes waste products from one business and supplies them as resources for another, thereby increasing resource efficiency and reducing waste. Perform a site survey to identify all features, such as trees, ecologically sensitive areas, climatic data, and slopes, etc. Engage consultants, such as landscape architects, geologists, ecologists, and environmental engineers, to perform a comprehensive site analysis. Select a site which supports a wide range of uses and which can produce a density capable of supporting a viable transit system and commercial activity. Select a site which contributes to a diversity of activities, both social and economic, and which offers a range of stable employment opportunities for the community. Select a site which contributes to the health and education and recreation of the community. Urban redevelopment. Favor infill development over greenfield sites. Provide compact and dense development. Reuse and renovate existing buildings. Brownfield redevelopment. Favor brownfield sites over greenfield sites. Favor ecologically benign remediation strategies such as regenerative landscaping. Gain community support for cleaning brownfield sites. Include remediation experts on the design team. Treat contaminated soils on site. Demonstrate to clients how to increase land value through environmental cleanups. Transportation issues. Choose a site within walking distance from a transit system. Plan and design the development or the building to include mixed uses and high densities. Encourage on-site pedestrian circulation by incorporating pedestrian paths in all new developments with access to existing paths. Provide secure indoor-outdoor bicycle parking for occupants and guests. Provide changing facilities for cyclists. Site impacts. Design compact and dense developments to reduce site disturbances. Avoid locating buildings within or close to ecologically sensitive areas. Design and incorporate green roofs. Locate new buildings on previously disturbed parts of the sites. Preserve all the natural features on a site. Erosion and sediment control. Minimizes soil disturbance during construction. Conserve as much as possible of the existing vegetation on any site. Provide long-term structural control and stabilization of soil. Reference provincial environmental control regulations in all specifications. Landscape and exterior design. Design all landscapes to accommodate local precipitation and water conditions and to minimize maintenance and use of chemical pesticides and fertilizers. Coordinate the landscape concept with energy strategies, stormwater control, water collection, gray water treatment, lighting strategies, and productive gardening. Designate habitat for local species in local soil conditions. Avoid lawns as they require more maintenance and water than other solutions. Test soils to determine nutrient content, organic matter, and necessary soil modifications. Use drought-resistant, low-maintenance native plants and non-native plants that are well adapted to existing soil conditions. Use native plants in landscape plans. Utilize impervious paving and walkways sloped towards landscaped areas. Develop a composting program to continuously add nutrients to landscaping. Provide interior planting for better indoor air quality. Site water systems management. Use swales and retention ponds to facilitate natural infiltration. Control water runoff and promote percolation of the groundwater for irrigation and to recharge natural aquifers. Redirect building stormwater and gray water to irrigate landscaped areas. Do not use potable water sources. Control and reduce off-site discharge of stormwater. Collect and store rainwater for use in toilets and urinals, irrigation, or for washing vehicles. Heat islands. Provide shade to all surfaces using native vegetation. Specify highly reflective, light-colored materials for hard landscape surfaces. Specify highly reflective, light-colored, and high-emissivity materials for the roof. Provide green roofs whenever possible. Light pollution. Favor downward exterior lighting instead of upward exterior lighting. Use the services of a lighting professional for exterior lighting. Incorporate safety and energy conservation features when reducing light pollution. Water efficiency. Water-free landscaping. Include a landscape professional on your design team who is knowledgeable about water-efficient designs. Complete a soil analysis for better native plant selection. Use native and drought-resistant plants. Water-efficient irrigation systems. Provide water-efficient irrigation systems appropriate for the local climate and for local plants. Collect and store rainwater for landscape irrigation. Provide greywater irrigation systems. Water efficiency fixtures and appliances. Specify water conserving plumbing fixtures and fittings. Specify water and energy conserving appliances. Water demand and wastewater production. Assess the different water needs of the building users. Determine the level of water quality needed, potable or non-potable, based on its use. Incorporate innovative wastewater treatment systems. Wastewater reclamation. Allow for modular plug-in purification systems for building adaptability in the future. Use gray water for landscape irrigation and toilets. Energy and atmosphere. Polluting emissions. Specify building products manufactured with no damaging refrigerants such as CFCs and HCFCs. Phase out existing CFC-based refrigerants when retrofitting existing buildings. Factors affecting pollution. Minimize the distance between the project and the energy source. When possible, select low-impact, efficient energy sources. Embodied construction energy. Specify materials with low embodied energy and low life cycle impacts. Use design solutions and construction techniques requiring low use of heavy machinery and energy-intensive construction. Provide natural materials that are locally sourced. Evaluate embodied energy in relation to recycling potential for various products. Deconstruction energy. Provide design solutions with connections and details that facilitate deconstruction. Reuse and/or recycle existing buildings where possible. Compact and efficient buildings. Design compact, efficient buildings to minimize operational energy. Explore ways to make more efficient use of programmed areas. Use simple, lean design approaches. Coordinate energy consumption budgets with building users. Establish temperature tolerance guidelines with the client. Energy-efficient products. Select energy-efficient HVAC equipment. Design to low interior lighting levels and incorporate maximum daylighting. Provide light levels appropriate to the task at workstation location instead of high ambient light levels. Minimize the number of fixtures. Use suitable, high-efficiency fixtures. Incorporate lighting controls, including photocell sensors to monitor daylight and occupancy. Develop plug-in designs that allow for flexibility in fixture location and fixture type. Minimize appliance use or use more efficient appliances. Specify energy-efficient equipment. Building orientation. Orient buildings to take advantage of winter solar gain. Provide year-round shading to western exposures. Provide summer shading for southern exposures. Incorporate shading using landscape or integrated with the building. Orient buildings to allow for the addition of solar panels and other plug-in elements. Thermal performance. Increase thermal performance, insulation, or R values of the building envelope. Specify efficiency glazing. There are several Canadian suppliers. Use details that contribute to thermal performance, such as double-wall glazing systems. Passive systems. Release hot air to the exterior in summer and recirculate warm air in the winter. Maximize the use of external air in temperate swing seasons, spring and fall. Use wind pressure differential, stack effect, and air paths through the building to facilitate natural ventilation. Shape the building to make use of natural ventilation. Provide operable windows. Design landscapes that work with natural ventilation strategies. Orient the building to take advantage of prevailing winds. Develop solutions for nighttime cooling. Provide temperature regimes appropriate to varying activities. Use thermal mass to capture heat during the day for release in off-peak hours to reduce demands for nighttime heating and daytime cooling. Seek low maintenance and simplicity in user controls. Review and challenge traditional temperature requirements for different activities and room types. Design interiors with good access to nature light, using narrow floor plates, courtyards, and atria. Redirect daylight with light shelves to extend naturally lit spaces deeper into buildings. Limit or angle west elevation glazing away from direct western light. Limit shading on east elevations to allow for morning solar preheating. Shade south elevations. Limit glazing on the north elevation to reduce heat loss. Energy sources. When possible, select low-impact energy sources. Design with the entire energy infrastructure in mind. Choose source, transmission, and storage systems that require a minimum number of transformations that reduce efficiency. Design buildings and developments that supply energy as well as consume it. Match energy source output with appropriate needs for electric or heat power. Use connections to the grid for on-site electricity generation, which can wind back electricity meters with excess power, thereby reducing total consumption. Design for adaptation to future and more sustainable technologies. Material efficiency. Building reuse or renovation. Reuse and or renovate buildings when feasible. Material reduction and efficiency. Minimize the quantity of materials used. Look for synergies within the functional program to reduce building areas. Maximize use of materials that do not require finishes and avoid the unnecessary use of finishes. Design with pre-cut or engineered construction products to minimize waste. Fabricate modules based on no cutting panel sizes. Develop structural systems based on building industry modular sizes. Plan buildings with facilities for recycling, sorting, and composting. Design for flexibility. Consider the varying lifespans of building systems and components. Design primary structural elements for an extended lifespan. Provide structural systems with minimum fire ratings, which may be easily upgraded. Design secondary structures such as non-load-bearing walls, guards, and infill floor panels to be demountable using adaptable materials. Develop adaptable plug-in service connection points with easy access. Use standard modules. Develop a modular system based on local standards in which components can be reused and reassembled. Design flexible spaces that can accommodate the maximum number of uses. Provide service zones to accommodate future upgrading of systems. Planning a model size that will satisfy a variety of space planning criteria. Designing for deconstruction. Design structures to be demountable. Require the deconstruction of existing building in all construction contracts. Use modular materials and thoughtful detailing to facilitate deconstruction. Train demolition personnel to deconstruct. Reuse salvaged materials close to the site. Consider waste as a resource. Embodied energy. Specify materials that have low associate energy costs for their full life cycle. Specify materials that have minimal environmental impacts for their full life cycle. Request full date from manufacturers and advocate for full life cycle assessments of building products